Ooh, if your KB is not consistent, all bets are off. I mean, that's that's a really good thing to point out. This is one thing some people hate about logic, which is, if you have a contradictory KB, you can derive bottom without the query. So, like all your queries become true because, hey, I got bottom. Hey, I got bottom. Hey, I threw this in. I got bottom. 1 + 1 = 2. I got bottom. Wow. 1 + 1 = 5. I got bottom. Traditional first-order logic does not handle inconsistency very well. It basically completely explodes.
So it's all right if our program sort of does not handle that well?
Yeah. Your program should be correct with respect to first-order logic, which means if it's inconsistent, then... Now, if you're doing set of support, then you can't resolve the KB against itself, so that's interesting. Maybe it wouldn't come up. Whoa, another reason to use set of support. Other questions?
When do you check to see if your knowledge base is correct, consistent?
Dun, dun, dun! Semi-decidability! Let's just grind on the knowledge base until we don't resolve bottom. So I hear we have multi-core computers now. You can just take one core and just run with it. But you will run out of memory. That's the only problem, is that every time you resolve, you generate something, and maybe you do, even if you do assumption checking, maybe it is something new. So, maybe it's P of f of f of f of f of f of f of x. So that can be tough. It's a big flaw. I don't mean to minimize it, the fact that logic explodes when on inconsistency. They have all these movies where, there's some killer robot, and then they say, I love the person that beats me, or something very inconsistent that's nonetheless true for humans, or... Yeah, that thing, and the robot starts, smoke pours out, and that sort of thing. You can think of that as the theorem prover overheating the cores, because it's now proved everything true. So we talked about the first one here. So if there are no more questions, just other random things you should know about first-order logic. Now that now you know everything you need to know to do the assignment. For next Monday. Some logics have this quantifier built in, which means there exists a unique x, such that P of x, but this is just syntactic sugar. Don't think that's anything cool. It's just you have to use equality, but there exists an x, P of x, and for all y that's not x, then not P of y. Okay, so the x is unique. So this is the I can only hold one thing at a time thing that we already did. So some logics give you the syntactic shorthand for that built in. Your theorem prover won't, but that's okay. Okay, this is very cool. Sometimes when you ask a query, you don't just want yes or no, you want the answer. Who is Caroline's parent? Not does there exist an X such that parent X of Caroline? Okay, fine, but who? This is the sort of theorem proving CSI version. Give me the answer. Who did it?
So instead of having a bottom, you just have something which you test for equality against?
Kinda. We're going to get a new piece of paper, and let's do this. Let's do this out. Father of, let's see, father AB, father CB, father XY, or parent XY Who is Caroline's parent? Who is Caroline's parent? Okay. Who is Caroline's parent? 1, 2, 3. The query, who is Caroline's parent? There exists an X such that parent of Caroline, X. So traditionally we would ask this question, like, does there exist an X such that X is the parent of Caroline? But if we actually want to know who, or what, or where, or when, then what we do is we use this little trick where you have what's called the answer literal, and you just append it onto your query. I forget if you do it before. I think you do it after negation. I think you do it after negation. Let's see. The negated query. Not there exists an X, P of X is, what's that going to be? Who can negate this query for me? Not there exists an X, P of C, X. Help me out here, C and F. So not there exists means for all x, not that. And we have to get rid of the... yeah, I don't think we need the Skolem function because not there exists an x p of x means for all x, not p of x. I think so. I think this can be for all x, not p of c of x, and then we just drop the quantifier. So now we just stick on what's called the answer literal, which says, hey, x is the answer. And then we do regular old theorem proving, except instead of looking for bottom, we're just looking for ants. We're just looking for the answer. So here's our negated query. Somebody help me out here. Let's do some resolution. Jeff. Jeff is going to do the negated query. Plus 3 equals, we'll call it 4. And that gives us not father of x, y, except that we've resolved, unified x with c. So cy and y with x. So ants of y. Okay? Who's next? Jen. What can we resolve with this new? We have a negative f here, so we're looking for an f to collide with it. We know we've got two choices. Yeah. No. No. This is where my nasty little habit of not standardizing apart is causing confusion. This is x1, this is x2, and this is x3. Yeah. If you have trouble with that, then maybe you ought to standardize apart. Yeah, this is not p of c in x3 or ants of x3.
But then does it become x2 and...
Yes, then you unify x2 and x3. Yeah, maybe I should standardize apart in class, but like I never do it at home, so I feel like I'm lying to you. Sorry?
Do you do this at home a lot?
That's my business. Okay, so wait, we gotta unify this with something. Gotta resolve it, and so there's nothing else that mentions ants except for not Q, and it's the same polarity. So we got to find something different. There's no negative ants anywhere. So we have a negative f, so we got to look for a positive f to unify with it. We have two choices. This one is not going to work because we can't unify constant A with constant C. So that leaves us one choice, Jen. Yes. We can make these look the same by substituting for y the constant b. So we end up with the answer is Bob. I think wasn't it Bob? Yes. So who's Caroline's parent? Bob. So a theorem prover just answered a WH question. It didn't just say yes or no. It told us what we wanted to know. Hooray. Go AI. Any questions about answer literals? I think the grad student has to implement them. Yeah. We talked about resolution strategies already? Whoa. Okay. Ooh. Oh, man. Semantics. Do we really want to do that? Okay. Well, it's nice to do semantics. It makes you feel like you know what's going on. I can do semantics last. We can skip ahead. Do the other stuff first if you want. Oh, it's complicated. It's nice, though. We have entailment coming back again. So remember back in propositional logic when life was easy? And a possible world in propositional logic is a what? Anyone remember? Nathan? Well, I think of it as the other way. Yeah, but the propositions get either true or false. So it's an assignment of true and false to all the different propositions. So you have different worlds and all possible worlds, and there are only some worlds where the formulas in your KB are true, and those are the worlds that your little robot thinks it might be in. Now things get a little more complicated because we don't just have propositions anymore. In fact, thank God we don't have propositions anymore. We got these predicate things and constants and variables, and someone was talking about some physical symbol system thing with designating symbols, and it got a little bit philosophical. Well, yeah. So a possible world in first order, the analog to that in first order logic is something called an interpretation. And an interpretation maps constant symbols onto actual things in the world. This is where it's a sort of a way things could be designating. It maps each function symbol onto a particular function. Like a function, remember, is just a big table. If you're a math person who has no problem with infinity, a function is just a big table where for this input, that's the output. For this input, that's the output. If the input is fish, the output is Bob. If the input is brown, the output is peanut butter. And it maps each predicate to a particular relation. If the input is Bob and Alice, then the output is true. Or then that's true. So that's what an interpretation is. And so you can think of there being a zillion possible interpretations of some KB, and the ones that the robot thinks might hold are the ones where the sentences in the KB are true. Now, and that means those interpretations are models of the KB. A model of a KB is an interpretation which makes it true. So, famous Barbara Bush is true under the intended interpretation. So the interpretation, everyone loves to talk about the intended term interpretation. That's what I was thinking when I wrote down the KB. But of course, the computer doesn't know what you were thinking. As far as the computer is concerned, every interpretation that's where the KB is true is a possible world. So if you want to only be talking about the interpretations in which Barbara Bush is true, you had better say famous Barbara Bush in your KB. Now, there are lots of other interpretations. There's one in which the symbol Barbara Bush maps to Joe Schmo. And I guess Joe the plumber might be famous, but Joe Schmo is not famous, except in my class. So that interpretation is not a model of the KB, because if this sentence is in the KB, then this famous Barbara Bush has to map to someone who is mapped by famous onto true. So if you like logic, then you'll want to know this kind of stuff. Otherwise, you'll just have to make sure you can deal with these words when I tell them to you. So a KB is satisfiable if it has a model. So that's just like propositional logic. Entailment, we've talked about ad nauseum. If Q is true in every model of P, then P implies Q, or entails Q. Implies, yeah. Ugh, don't let me make that mistake. Now, this is with the double turnstile, and which means that we're talking about semantics here. This is entailment. When you want to say that something is derivable from a KB, you use a single turnstile. So, for example, we had KB, KB plus negated query, negated query and the KB. This is derives, and sometimes people put the inference rule that they're using down here, like it's derivable using resolution, but not always. Sometimes they put the number of steps or something, but anyway, single turnstile is a syntactic notion. Just means by applying the crank, you can get this. And then it's a question of soundness whether this is in fact entailed by this. Now, I told you and waved my hands a lot and gave you a few examples indicating intuitively that resolution refutation is sound and complete. But someone has a proof somewhere. So in fact, this derivable does match up with entailment. That's what it means to be sound. Any question about that? People okay with the idea of entailment and valid, true in any interpretation. So people love to throw this word around when they're talking about logic. It's like, oh, my assignment does blah. Is that valid? It's like, I hope not. I hope the KB is ruling out some interpretations. Otherwise, it's not a very powerful KB.